Hello, so today we are going to do this Leetcode problem 538, convert BST to greater tree. This is part of Leetcode April daily challenge. And so the problem says that we get a root of a binary search tree and we want to convert it to a greater tree. And essentially what this means is that the definition of greater tree that they give us is every key of the original BST, we change it to the original key plus the sum of all the keys greater than it. That's pretty much it. And then we return that new updated BST tree. And of course here they just give us a reminder that a BST is a tree where the elements on the left side are smaller than the node's value and the elements on the right side are bigger. That's pretty much what this says. And that, like, it's recursive. Subtrees are also binary search trees. And now let's just take a look at the example that they give us here. So what's happening is that first, the rightmost one is just 8. There is no value greater than it here. And so it's just 8. And then for 7, we put 8 up. And so we get 8 plus 15, 8 plus 7, that's 15. And then we go up again, 15 plus 6, that's 21. And then we go here, 21 plus 5, that's 26. And then once we are done, we go up again, and that's 26 plus 4, that's 30. And so you can notice here we go from the right first, right? Then we go to the node, and then we go to the left side, and then we return up to our parent, right? So that's kind of what's happening here. 30 again, here we go back here to 30, to this node, but we need to go to its right first. So we go all the way down here, and then when we reach the right, we add 3. So we have 33 now, and then we go back up, we add 2, we get 35, we go back up, we add 1, we get 36, and then we go to the left side, add 0, and we get 36 back. So that's kind of the problem here. Now let's see how we can solve it. Okay, so let's see how we can solve it. So I'll solve it in 2 ways. One is, the second one is shorter, but it's slightly harder to understand. So let's start with the simpler one first. So we know that with binary search trees, oftentimes we need to do some traversal that is either in order, pre-order, or post-order, right? So often we do that. So here we know that we want the right first, and then we want the node, and then the left. But what we can do is first let's just explore the in order traversal and see what we get. So in order is we go left first, and then we visit the node, and then we go right. And so if we apply it here to this, then what we'll get is so left first, which means 1, node 2, and then right 3, and then the node 4. So this was, we explored the left side, so we explored the node, and then we explored the right side. And so this would be for us 4, and then 5. Okay, so this is the in order traversal. Okay, and what the problem says we need to do, if we go again, is just like this. So let me just draw this again, 1, 3. So what the problem wants us to do is replace 5 first here, and so we propagate 5 up. 5 plus 4, that's 9, so we put 9 here, and so we go back with 9, we go to the right side with 9, and we replace 9 with 9 plus 3, which is 12. Okay, and then we go back up with 12, we replace this with 14, 12 plus 2, and then we go back here, we replace 1 with 14 plus 1, which is 15, right? So you can see this is actually just doing the suffix sum of this, right? 5, and then add 4, and then add 3, and then add 2, and then add 1. And so if we do the suffix sum of the in order array, suffix sum of in order, then we'll get okay, 5 plus 4, that's 9, plus 3, that's 12, plus 2, that's 14, plus 1, that's 15. That's exactly the array that we want, the tree that we want. And so now the problem, once we get the suffix sum this way of the in-order traversal, we can just start popping and putting the elements in the position. So we can just take this element, pop it, and then make it set the node value to it, the rightmost node value to it. So let me actually write this down. So the steps would be 1, go to the far right, okay, and then 2, set value to basically to this suffix pop. So we pop the last element, so we just use pop, and then we set the value, and then we go back up the recursion and set the value to the next one, and so we set the value to 9, and then we do the same thing again, we pop and set the other value of the tree. So we just traverse the tree, and as we unfold the recursion back from the right side, we pop a value and assign it, and so we assign next value, which is 12. So yeah, we need to go all the way to the right. So we recurse all the way to the right here, and then we change the value to 12. And then we recurse back up, we change the value to 14, recurse back up to the left side, and we set the value to 15. Okay, so basically after we set the suffix sum, we need, what we are doing here, let me just write it down, traverse with right first, with right, then node, then left. We can call this actually just in order, reverse in order traversal. So in order traversal we do left, node, right. With this we want to do right first, and then node, and then the left side. So we can just say this is basically just traverse with reverse in order traversal. Okay, and that's pretty much it, right? With this, if we do explicitly the list, the suffix sum of the in order list, that makes it easier to update the array. The second solution is a little bit harder because we would have to keep the suffix sum while we are traversing in the reverse in order traversal. And so I'll show that later, but for now let's write this solution here. Do the in order traversal, calculate the suffix sum, set the values while traversing in reverse in order traversal. Yeah. So yeah, let's see how that works. Okay, so let's do that. So first we said we need to write our in order traversal. So in order, and this would be with a node. And then of course we need the base case, we'll write that later, but the in order traversal is just doing the left side first. And then visiting the node, and then in order node right. What do we want? We want to return the list of values in order traversal. So let's just initialize the list for that before calling the function, and then now we can just append here. When visit take the node, we append the node value, right? And now we need our base case. If we reached a null node, we want to just return, right? And now we can call in order with root. And then the second step is to do the suffix sum, right? And so what would that be? That's actually just going through the list from the last element. And so that's, let's call it n here, and this is the length of, we want to start from the last element all the way to 0. With Python we need to do -1 here, and each step we decrease by 1. We are going from the end to the front. And so what do we do? With values at position I, we just want to add the value at the position before it, right? And then that will contain the sum up to that point, and each time we add. What I mean by that is if I take Let me just clarify that a little bit. So in our list that we saw earlier, we had the values 3, 4, 5, right? So what I'm doing here is just I go here at 5, okay. At 5 we don't do anything, but then we at n minus 2, let me update this to n minus 2. What do? We took 5, which is I plus 1, and add it over here. So we just add the previous value at I plus 1. And now we go back again. For 3, we just take the whatever was the suffix sum before it, and we add 3. And so that's 12. We go again, and we take whatever was before the suffix sum so far, and we add 2. And then here, same thing, and then we get 15. So that's exactly what we are doing here to calculate the suffix sum. So now that values contains the suffix sum, we need our function that updates the list with the reverse traversal, right? So let's define that function here. Let's call it maybe update, and with node. So we want to do reverse order, which means we want reverse in order. So we want right first, then visit node. Then after that, we want to do the left side. Okay. Now, what do we want visit node to be like? We just want to take, as we said, we want to take the last element of the list, and we want to set that, right? And so that's just will be node.val is equal to self.values.pop. So, and this works because we keep recursing on the right side until we reach the rightmost element, and then we start going back up to its parent, to its left side, and then we go back up to the parent of that one, and that's pretty much it. And as we do that, we keep extracting these values, and that will give us the right order here. So this is reverse in order traversal. And now what should we do if we reach the end? Well, we should just return. We don't need to do anything. And now let's see if now we need to call it, right? So we call in order. We have our suffix sum. And now we just need to call update. It already uses these values here. So we just do update on the root, and we return the root. Okay, so now let's run this, see if it works. It passes this test case. Let's use all the examples. It does. Okay, let's submit. And that passes test cases. Now, one thing we can do here, just to make this easier to understand, is we actually, for self.values here, instead of using a self value, we can just do this return plus a list with the value, right? This is equivalent to what we had before, and now values are just equal to the in order of the root. And here we'll return an empty list, so that adding it to this to a list will work, right? Since we are not modifying a value anymore. Yeah, so let's try this. And that passes as well. Now, one thing you might say is, okay, instead of doing in order and then calculating the suffix sum and then updating again, well, why don't we just start with this traversal and just keep track of the suffix sum as we are traversing, right? And that's valid actually. So let's just keep this, and we can just have the suffix sum. So this would be suffix sum. Initialize it to 0 instead, and we will keep track of it as we go instead of having the intermediary list, so we don't need in order anymore. And now here this is the suffix sum, so we haven't constructed it yet. We'll construct it as we are traversing. And so what we'll do here is we will construct it, which is plus the node.value, right? and now this will be equal to that. So before we were popping the suffix sum, but it's now saved in this variable instead, and so we'll assign that suffix sum there, and that's pretty much it. That's the only change we need to do. And looks like that passes those test cases, and that passes test cases as well. Yeah, so starting first with a clear list and calculating the suffix sum, and then modifying this to make it work, I find that easier to understand. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.